Hello, welcome to today's review. Today's learning target, I can divide a larger amount into smaller equal-sized groups by using partial quotients division. We're going to try a couple different things here today. The first, I want to illustrate a very simple partial quotients problem with some manipulatives, some blocks here. I hope maybe to give you just a little bit of a deeper sense or better understanding of what it is you're exactly doing when you use partial quotients division. So let's get started here. This is a group of 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a group of 10 blocks, okay? So this is our dividend, 10. We are going to divide 10 by 3, okay? And so we're going to use partial quotients to do this. This, I hope, is looking familiar, even if you're not 100% comfortable yet. We'll write our dividend underneath here, the division sign, and we'll write our divisor right outside to the left, just like that. So this reads 10 divided by 3. All right, so when we use partial quotients, we ask ourselves, how many groups of 3 can I make from 10? Well, let's say your first partial quotient was 2. You want to start with 2 groups of 3. So what we would do when we divide is to actually create the 2 groups of 3. So I could grab 1, 2, 3, and 1, 2. Let's do it this way. 1, 2, 3. So now I have 1 group of 3, 2 groups of 3. I just took those 2 groups of 3 away from the pile of blocks. And so how we record that in partial quotients division, the step we just did was to write, I'm going to start with 2 groups of 3, and 2 groups of 3, 1, 2 is equal to 1, 2, 3, 4, 5, 6, or 2 times 3 blocks, 6 blocks in all. So we'd write the 6 here, and the way we take away the blocks here that we just made into groups from the whole pile using math is subtraction. 10 minus 6. And for that, we get 4. That leaves us with 4. And this 4 here represents the 4 blocks we have left over. These 4. That's what this 4 is. What's left in the pile, right? Does that make sense? So then we ask ourselves the same question. We repeat the process. We ask, how many groups of 3 can I make from 4? Can I pull another group of 3 out of this, what remains in the pile? And the answer is yes, we can make one more group. So we'd write the 1 right here as another partial quotient. We do one, we make our group, right? Let's pull out one more group of 3. 1, 2, 3. Yikes. Maybe I'll overlap them like this a little bit. There we go. There's another group of 3, right? And 3 times 1 is 3. So 1 group of 3, that's 3. And just like we took this group away from the group it was sitting in, the pile it was sitting in, so too will we take that group of 3 away from the pile that it was sitting in. And 4 minus 3 is 1. We ask ourselves again, can we make another group of 3 from the 1 that's left over? Well, we just have 1 left in the pile. You can't take 3 away from that. You can't produce a group of 3 from the 1 left in the pile. So no, it's a remainder. So what we actually do in sort of like the real world with the blocks is we'd say, okay, what's our answer? Well, we have 1 group, 2 groups, 3 groups of 3. In partial quotient, that looks like 2 plus 1, adding up all of our partial quotients, 3 groups. So the way you read that is 3 groups of 3. And we have a remainder. We have 1 left over. That's this one. This 1 represents this 1 block left in the pile. So we'd write that as remainder 1. I hope seeing how these steps would look in real life if we had a pile of stuff that we were actually dividing up helps you to sort of better understand what it is you're really, really doing. Because I'm after a deep understanding here. I'd like you to really deeply understand what you're doing when you divide. And more specifically, how each of the steps in partial quotients relates to division in real life. So one more little activity here to review. I have the same problem written twice. I'm going to do it 2 different ways. And I would like you to observe the differences in the way I do these 2 problems, and then I'll ask you a question at the end, okay? So just watch me work, and I'll talk out my steps here as I work. All right, so let's do 436 divided by 8. All right, so one way to do it is to say, well, how many groups of 8 could I make? Could I make 10 groups of 8? That would be, let's see here, 10 times 8, that would be 80. That's pretty close. Maybe I could do 20 groups of 8, and maybe that's 160. Well, let's say I want to go with that. I could do 20 groups of 8. I could write the value of those 20 groups of 8, 160, and subtract. 6 minus 0 is 6. And let's see, I got to trade. 13 minus 6 is 7, and 3 minus 1 is 2. I'd have 276 whatever's left over. Let's say blocks on the table, just like in the last problem. And I could maybe do that again. I could say, well, I already know that 20 groups of 8 is 160. That's kind of close to 276. Why don't I just do that again? I'll do another 20 groups of 8. So 20, I don't need to do the math. It's sitting right there for me. I can just copy it down, another 160. I could subtract. 6 minus 0 is 6. 7 minus 6 is 1. And 2 minus 1 is 1 as well. And then I could say, okay, well, I have 116 left. How many groups of 8 could I make out of 116? Well, if I go back to my list, I see that I have 10 groups of 8. So I could try that. 10 groups of 8 is 80. Subtract that away. Take it away from the pile. That'll leave me with, let's see here, 36. And then I get down to a math fact. Let's see, that 8 times 4, my final partial quotient. 4 groups of 8 would be 32. That'd leave me with 4 left over, from which I cannot make another group of 8. So I would then add up. Oh, not add up. Oh, sorry. I would then add up my partial quotients. 20 plus 20 plus 10 is 50. Plus 4 more is 54. With a remainder of 4. And I would bring it up here, 54 with a remainder of 4. Now, that's one way to do partial quotients. And if that works for you, using smaller groups and using them more than once, great. You come up with the correct answer. No, that's great. Go for it. Do it the way you feel comfortable. But let me just show you this before you move away here. Let me just show you one other way to do this. So if I try to get the largest partial quotient I can to start with, watch how much faster the problem goes. If I try to say to myself, okay, how many groups of 8 can I make from 436? Well, let's see, 8 times, and what I'm going to do actually is I'm going to look here and just sort of round. 43, I'm going to pretend that's a 43. It's not, but I'm going to pretend like I'm looking at just 43 now. I'm going to say, well, 8 times what gets me close to 43? 8 times 6 is 48. That's too big. 8 times 5. Ooh, 8 times 5 is 40. 8 times 5 is 40. So 8 times 50. Ooh, 8 times 50, that's going to give me 400. And already, you notice I'm already as a partial quotient much closer to what's left. But then I could say, watch this now. I could say, but if 8 times 50 is 400, and I need a little bit more than 400, I could do a little bit more than 400. And I could do this step down here, the 4 groups of 8 is 32, just by looking at what's left over, the 36. Like I'm holding the 400 in my head. And I'm going to say, ooh, 36, that's like 2 or 3 or 4 more, right? And then what I could do is I could say, well, I'm going to go with 400. I'm going to just kind of guess 404. Well, let's go with 400. 400. Sorry. Let's go with 50. Let's go with 50. That's going to give me 400. Subtract 36. And then I use my reflex math facts. 4 times 8 is 32. Oh, and get 4. And then I'll just add up my partial quotients. 54, remainder 4. Do you see the difference? Just look visually at the difference here in these two problems. Look at this. We have this work here or that work there. And what I'm trying to remind you and teach you is, if you can use the biggest possible partial quotient you can discover, you can find to start, you're going to work much more efficiently. You'll get the problem done more quickly with less energy. That's efficiency. So I just encourage you to try that. But again, if this way makes sense to your brain, you're just learning and that's okay. Do it this way. You'll get the correct answer, right? You'll get the correct answer either way. And that's really the most important thing. And as you get more comfortable, then you can move up to being a little bit more efficient. But this is the goal eventually for everybody. I'd like you to become just like that efficient, okay? That's the goal for everyone, eventually. Not today, but eventually. All right, let's get to work with some practice problems. And today you're going to do those in Jamboard. So that's kind of cool, huh? I'm going to show you how to do that if I haven't already. And you'll get to try using your stylus to do some work on your screen today. All right, let's do this.